We're asked to evaluate this somewhat complex integral, and you're probably doing this question within the context of the various techniques of integration, and there are a bunch of them to choose from. And it isn't terribly obvious how this one is supposed to proceed. Generally, I recommend that if you're stuck on a problem, you try a substitution method first. Those tend to be the easier of all the methods. And that's what we're going to try here. And normally we do u substitution, but as we will see later on, we're going to just change the variable to t rather than u. It makes our lives a little easier later on. So we're going to let t equal the square root of x. And after making that substitution, what we would also want to do is square both sides of this. So if we square both sides, we would end up with t squared is equal to x. And then what we need to do is differentiate this equation. And so we're going to differentiate this equation with respect to x. So you have to use a power rule here. You'll bring the 2 down. You'll have 2t raised to the 1. And then chain rule requires us to multiply by the derivative of t with respect to x. On the right-hand side, differentiating with respect to x is easy because the derivative of x with respect to x is just 1. And then what I typically like to do is solve my equation for dx. So I'm going to multiply both sides of this equation by dx. The dx's will cancel out on the left-hand side, so we can just sort of erase them. And then 1 times dx is just dx. So we can see that dx is equal to 2t dt. So with that little preliminary work, why don't we go ahead and rewrite the integral in terms of our new variable, which is t. So we're going to have 11 times the arctangent. Now the square root of x will be substituted with t, and then the dx will be substituted with 2t dt. Now perhaps we can clean this up a little bit because we have 11 times 2, which is 22. So we'll just rewrite this as 22 arctangent of t times t dt. Now we have to apply one of the more specialized techniques. We're going to be using integration by parts in this case. And we recall that when doing integration by parts, we have to use a u as well as a dv. And this was the reason why we chose earlier to use t rather than u. We were sort of in anticipation of using the integration by parts method, which involves the variable u. So we kind of saved it for this point in the problem. We're going to let u equal the first expression here. It's going to be 22 arctangent of t. Therefore, dv will just equal the rest of the expression. So it will be t dt. And then when doing integration by parts, what you're going to do is you're going to need to take the derivative of your u equation. So you're going to have du equals 22 times the derivative of arctangent of t. The derivative of arctangent of t is just 1 over 1 plus t squared. We can actually simplify that by saying du equals 22 over 1 plus t squared. We should include the dt as well for technicality's sake. Now, on the other hand, we have dv. We need to integrate to solve that for v. So if we integrate, we get v equals t squared over 2. So those are the parts, and we're going to put them together using the parts formula. It's uv minus the integral of v du. So here we go. We'll take our u, which was 22 arctangent of t. We'll multiply that by v, which was t squared over 2. Then we'll subtract the integral of our v again, which is t squared over 2, times our du. And du was 22 over 1 plus t squared dt. Now let's simplify these a little bit. This first expression here, we have 22 divided by 2, so that's just 11. And then I prefer to put my t squared first. So it's 11t squared arctangent of t minus an integral. Now again, we have 22 divided by 2, which is 11. Let's factor that to the outside. We have 11 times t squared over 1 plus t squared dt. Now, integrating this t squared over 1 plus t squared is itself a bit of a challenging problem. It's a polynomial divided by another polynomial, but you'll notice the degrees of the polynomials are equal. We have a degree 2 in the numerator and a degree 2 in the denominator. Typically, what you need to do there is a little bit of long division in order to simplify it. So we'll just kind of take an aside here and do a little bit of long division. You'll take t squared and you'll divide that by, well, let's do t squared plus 1 rather than 1 plus t squared. They're equivalent. So this t squared goes into this t squared one time. So you'll put a 1 here, and then you'll multiply. So you'll have t squared plus 1. We can put a 0 here, and then you recall that you'll just subtract. So t squared minus t squared is 0. 0 minus 1 is negative 1. And so you can actually rewrite that integral that we put in yellow there as the integral of your quotient, which was 1, plus your remainder over your original divisor, t squared plus 1, like that. Now we can clean this up because we have a plus and a negative there. Together, those just make a minus. So we'll just put a minus sign there. And then we got to rewrite everything else that we had. We had the 11 on the outside, and then we had this other term, 11t squared, arctangent of t. So now we can finally integrate that expression, and we'll go ahead and do this with respect to t. So the integral of 1 with respect to t is just t, minus, now the integral of 1 over t squared plus 1, that's a common integral. It's not super common, but it's one you'll encounter often. You might see it more often as 1 over x squared plus 1, but whether it's x or t, it's the same integral, and the integral turns out to be the arctangent of your variable. So in this case, the variable is t. So we've got a good answer in front of us, except we have to remember a couple of things. We need our constant of integration, but then we have to recall that t, if we go back up and look at some of our work, aha, there it is. T was equal to the square root of x. So you're going to want to go back and replace all of your t's with square root x's. So you're going to have 11 times the square root of x squared times the arctangent of the square root of x minus 11 parentheses the square root of x minus the arctangent of the square root of x, and then plus c. Over here we have the square root of x squared. And of course, we all know that that's just x, so it's probably better just to call that 11x. And that should complete the answer to this puzzle.